Okay, we are into the ninth question of this paper, June 220, paper 3-2. We have been given two curves with their equations. One is y is equal to cos x, other is y is equal to k over 1 plus x. It says, show that P satisfies the equation tan P equal to 1 over 1 plus P. Let me write this equation for a moment as tan x equal to 1 over 1 plus x. And later on, we'll be changing this x with the p, okay? So one thing is that they are both intersecting at this point, so we can equate them first of all. So this gives me cos x that is equal to k over 1 plus x. That is my first equation. Secondly, we know that if you draw the tangent at this point, that would be a common tangent over here, okay? So that means they both have the same gradient of this tangent. So we can equate their derivatives as well. So from the first equation, you have dy by dx that is equal to minus sine x. And you can put that equal to the derivative of the second equation. This is basically y is equal to k into 1 plus x to the power minus 1. When you differentiate it, you must get minus k into 1 plus x to the power minus 2 times 1. So this is going to be minus k over 1 plus x square. You cancel the minus with the minus. So we have equation here. This is going to be sine x equals. Now from this equation, can I have k from this equation? That k would be 1 plus x into this cos x. So I'll be substituting this k with this expression, okay? So this is 1 plus, oh, there's a whole square. Why did I write it like this? Okay. So 1 plus x, and then there is cos x over this 1 plus x whole square. So this 1 plus x is cancelled by this. So you shift this cos x to this down here as a denominator. So you have sine x over cos x. Okay. That is equal to 1 over 1 plus x. And this becomes this. And then you change your x with p because here your x coordinate is p, okay? This is your value of x. So if you put x as p, you get to this equation. This required equation is derived here, okay? Okay. So that is how you get this required equation. Next it says, um, um, it says that use the iterative formula this to determine the value of p correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Okay, so here you have to use your calculators, guys, and let me clear this off. Okay, so you have to decide that what would be your first value. Like, this is your iterative formula here. Guys, you must be ready with your calculators. Okay. This is 1 over 1 plus Pn. So what would be your first, when you have to start this, solving this, so what can be your first value? This is between pi by 2 and this is going to be 0. This is, you can start from point 1 because, sometimes this is not good to start from 0. So you can have point 1 over here. So this is quite sensible, or you can start a value before this pi by 2. Okay, guys, so let's start from this um, this P1. Let me say this P1 over here is going to be 0.1. Now, keeping your calculator's mode in radians, please tell me what is going to be P2. This is mandatory part. You have to show this working here. That is going to be tan inverse of 1 over 1 plus, and please keep that inside the brackets here, okay? So who will tell me what is this? Yes?
Sir, 0.7378.
Correct to 5 decimal places, beta. 0. 73781. 781. We go back into this.
सर अगर वो 815 है तो फिर 82 ना कर दें.
Yes, but it has to be 82. Now, without deleting it from there, you put it back here in like, you know, as tan inverse of, like this is what you have to write. This, like your computer, I mean, your calculator's display should be showing this. And here is your answer now, okay? And now you only have to press the equal button. Yes, please tell me, what do you get? Quick. Yes. I'm waiting.